Hi guys, welcome back after a long time. Yes, uh, can you guys hear me? Quickly confirm in the chat. How are you doing? How are you doing? Quickly confirm in the chat. Can you guys hear me? Let me see who is online. Madhu. Okay, great. Thank you, Ramai, Madhu. Okay, so without any further laid off, without anything, any delay or anything, let's get into what you see. The topic: network analysis previous year questions from APGENCO APTRANSCO. In this session, what I'll be talking about. See, this session is something special which you will never see that so far in YouTube. Okay, this is the first time on YouTube, not on PySquare channel. It's overall on YouTube. It's for the first time. We'll be giving a question. It's artificial intelligence driven quiz. I'll throw some questions the way we normally see. MCQs will be there with options. 4 options will be there. Now we can directly give it in the chat. The option, if it is option A, B, C, D, or whatever the option is, right? Just give the option A, B, C, D. So your poll will be automatically taken into the feed, and that will be displayed over here. Okay, the feed will be automatically. It will capture the options. It will give the percentage how many people are opting for A and B and C. I think you will better understand once we go to the session. Okay, so let's jump in. Let's jump into the first question. Okay, are you guys ready for the first question? Are you guys ready for the first question? Are you guys ready for the first question? Okay, he's saying after a long time. Okay, nice. After a long time, I'm back. Yes, that's true. Yeah, coming to the first question. Shall we jump into the first question? Yes. Great. First question on the screen. You have 2 minutes time as it is. Timer is running. Within 2 minutes, you will have to answer this question. Yes, it's already given. You have to, their options, option A, B, C, whatever, that will be displayed. Okay, in the poll. Let's see.
The first step towards achieving your dreams is having the right coach. Get the best education with PySquare Academy and make your gate electrical dreams come true. Download the app now.
Nobody has answered it. Try first.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Just 10 seconds more. It's a bit bad that no one has answered so far. You got 2 minutes of time, but you didn't answer it right. Anyways, let's jump in. Let's jump into the answer for this question. Let me answer this. Read the question what it says. Two light bulbs are connected in series across 120 volts battery. You have a source, you have a battery source whose uh, voltage is 120 volts, and two bulbs are connected across this 120 volts battery. They're in series. Okay. And bulb 1 is consuming 40 watt and bulb 2 is consuming 20 watts of power. Okay. So total power is how much is consuming? The total power consumed is how much? Total power P is equal to the sum of these two. You can directly add the powers to get the resultant power. Total power is 60 watts. Okay. So can you quickly tell me what's the current flowing in this? So total power consumed is 60 watt. So total power delivered by the battery is how much? 60 watt. That's it, right? So it is giving 60 watts, means what is the current flowing in this? 0.5 ampere. So the current flowing in this is 0.5 ampere. Now quickly tell me, what is the resistance of this bulb? You know the power, you know the current, you can find out the resistance, because resistance is equal to P is equal to I square into R. So R is equal to P by I square. So P is 40, 40 by, let's take it as R1, 40 by I square is 0.5 square. So here this is 40 by 20 by 0.5 square. We got some answers. Yes, he is saying 0.5 is the current. Okay, fine. So 20 by 0.5 square. So tell me what is this resistance value quickly. What's the value of resistance you got? Yep, 160. Okay, so this is 160 ohms and this is 80 ohms. So this is 160 ohms and this is 80 ohms. Now this 160 ohm resistor is connected, this 160 ohm resistor is connected across, take it as a bulb whose resistance is 160 ohm and this is 120 volts. So you need to find out the current, or simply V square by R is a power. So 120 square by 160, if you solve it, you will be getting 90 as answer, 90 watts. That's it. Anything complicated here? What you see? Anything complicated? Nothing, right? Then why take more time? Anyways, let's get into the next question. There we'll see how we are going to answer. I'm moving to the next question. Ready? Okay. Try this. Try this one. Theoretical one. I think you can pretty well answer this. Give the option. Which option is correct? So that our AI can detect and it will display your poll.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Okay, I think for this you don't need 2 minutes of time, right? 1 minute is pretty much enough. But yeah, we got a couple of answers, but different answers we got, strangely. Let's see who is right among these.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Okay, I'm not waiting for a long time for this specific question because a question itself is an easy one. Okay, so I'm moving to the uh, analysis of this question. The question says a network consists of several inductances connected in parallel. They are connected in parallel. See, one thing is pretty much clear to us. If resistances, or for that matter, if anything in ohms, be it a resistance, be it inductance, be it capacitance, be it impedance, anything whose unit is in ohms, you can apply series and parallel formula the way you will do for resistance case. The way you do for resistance case, you can do the same thing if it is, if it is ohmic, be it inductive reactance, capacitive reactance. If unit is ohm, you can apply the rules and regulations of resistance to those ohm. And similarly for Henry's also. For Henry also, you can apply the same logics. You can apply the same logics what you applied to this Henry also. So for series, if resistance is in series, then what you'll do? R1 plus R2 plus R2, you will do that. If they're in parallel, you will do 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus and so on like this. So it is said for parallel, it is for inductances. So in place of L, replace with L. In place of R, replace with L. That's it. So answer is sum of reciprocals of individual inductances. This will give 1 by L equivalent, not L equivalent. The question is asked for L equivalent. So the reciprocal of sum of reciprocals of individual inductances, this is right. So some of you might know the answer, but in a hurry you must have choose option C. But the right answer is option D. So you need to be very careful. Okay. So I think Madhu has changed the answer from C to D. That's what. You need to be very careful, dear. I'm moving to the next question. You got 2 minutes time. Excuse me.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
We already got the answer from Madhu.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square
Let's see
Academy
what others got to
and
do.
make your gate electrical dreams come true. Download the app now.
Kiran is saying B. Okay, the time's up. Let's look at the question. You answered right, both of you. So come to the solution for this. Of course, there will be a couple of ways to analyze once you know the concept. Okay, so let me give my approach. A DC source has an output voltage of 30 volts. You have a DC source with open circuit voltage. So basically it means VTH. It is saying VTH is equal to 30 volts. And internal resistance of 1.5 ohm means RTH. I can take it as RTH, which is equal to 1.5 ohm. And the load is connected to a source. Now you have a source with internal resistance like this. This is 30 and this is 1.5 ohm, and it is connected to a load in such a way that maximum power is transferred to the load. So then what is the maximum power dissipated in the load? Now from the concept of maximum power theorem, 30 volt is here. Can you tell me what is the voltage across this under maximum power? I'm not asking for resistance value, I'm asking for directly voltage value. What is the voltage across this under maximum power? Tell me. Yes. Look at the circuit. Look at the circuit and tell me what is the voltage under maximum power. You don't know the resistance, but yes. No, it is a 15 volts. Voltage will be 50%. Directly you can say without actually taking the value of resistance. So voltage will be 50% of the input voltage. So it is 15 volts. And you know, its resistance value is 1.5 ohm. These two must be same. Then maximum power will be transferred. Then what is the power? Power in this? Power in this is simply V square by R. Voltage across the resistance is 15 square. This V is not the input voltage. Voltage across the resistor square by the resistor value 1.5. So it's 15 into 15 by 1.5. Directly you can say it is 150 watt without using a calculator or anything. You can answer it. Okay. So is this clear or you having any confusion? Any confusion with this or clear? Shall we move to the next question? See how simply questions are asked. I'll move to the next question. Get ready. Yep. Try this.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
No, I don't expect you to take more time for this question. This is an easy one. You should be able to answer this very quickly.
The first step towards
But I don't know why you're taking much time.
the right coach. Get the best
Okay,
education with
we
Pi
got some
Square
answer.
Academy and make your gate electrical dreams come true. Download the app now.
Yes. Now we got a right answer. But 5 seconds, if you want to change the option, you can change. Those are giving wrong answers. But you should know why you are changing the option. Okay, time's up. So here, what's the question asked? It is asked for polyphase circuits. To be more precise, it's a 3-phase circuit. It's asking for 3-phase circuits, 3-phase system. Now for three-phase system, there are certain basic rules are there. What are the basic rules? Basic attributes I would like to call. What are the basic attributes of this three-phase system? If it is a balanced three-phase system, yes, it is a balanced three-phase system. For a balanced three-phase system, at any instant of time, if you add all the three phases, the resultant will be 0. And we have a beautiful animation on the concept of RMF, rotating magnetic field theory, on YouTube itself. You can check that. There you will see how the resultant will be 0. And also I have given an interesting simulated video on attributes of three-phase, some important relations of three-phase. So those will be very much helpful to answer this question. Straight point, what's the point? When you add all the three phases on instant to instant basis, at every instant you will get the result as 0. Now, Y phase voltage is minus 90 and R phase voltage is plus 30. Now B phase voltage will be such that the result will be 0. Now for the result to be 0, what should be the value of this B phase? Yes? Yeah. Plus 60. If it is plus 60, then this whole thing will be 0. So answer is option D. Option D. What happened, Madhu? What's going on? I'm moving to the next question. I think it's clear. I told you details about phase order, what is a phase order, and the relation, how you get that relation, line voltage and phase voltage relation for star and delta. All these things already discussed in other videos. You can check the playlist, okay, network analysis playlist. There you will get the complete understanding. And along with that, Y sinusoid, Y 50 Hertz, all these things are very clearly explained with the help of beautiful research. My backing good research. I explained about that. You can check those videos. I'll move to the next question. Shall I move? Shall I move? Give it a thumbs up. Give it a thumbs up. Give it a thumbs up.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
No, you cannot miss the polarity, dear. Anyways, try this. Forget about that.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Forgot the formulas, it means. I didn't get any answer, which means what? You forgot the formulas, maybe. Okay, time's up. Let's get in. Let's get into the solution. So there are a couple of ways, obviously, to answer this question, but my way of solving this is I have given some beautiful rules in our course, network analysis course. With the help of those rules, things will be a lot more easy. No? And you don't have to memorize the formulas. If you follow those techniques, you don't have to memorize the formulas. If you know series resonance circuit, series RLC resonance circuit, then parallel RLC, series parallel combination, all these combinations will be pretty much easier without actually memorizing the formulas of all those. You don't have to worry about memorizing the formulas if you know that technique. Let me give that technique. Okay, what is said? This is said here. A coil of inductance 240 millihenry and resistance is 75 ohm is connected in parallel with a capacitor across 30 volts variable frequency supply. Let me draw the circuit. This is what the voltage source, which is having 30 volts with a variable frequency. Of course, I can set any value of frequency. And the resistance is having something how much? 75 ohm resistance. It's a coil. The coil is having some resistance. It is having some inductance. It is not talking anything about the coil capacitance, so forget about that. Ignore that. And there is an extra capacitor which is connected in parallel to this coil, whose capacitance value is not given. Fine. Interesting. Now what is said? It is said the current drawn by the circuit is found to be minimum when supply frequency is 1 kilohertz. So what does it mean? It never specified anything about resonance. But this statement, this interesting statement says, current drawn by this circuit is minimum under what case? Under resonance. When it is at resonance, then only current will be minimum if it is a parallel circuit. Okay. So if it is a series circuit, current will be maximum. So this means what? This entire line is to say a resonance frequency is 1 kilohertz. That's what, instead of saying that, he gave it in 3 lines. Now he's asking about the approximate value of Q factor and the bandwidth. Q factor and bandwidth. And if you know the Q factor, and bandwidth will be very easy to calculate by using resonant frequency. The relation between bandwidth and resonant frequency is bandwidth is equal to a resonant frequency by Q. If the unit of, bandwidth is equal to resonant frequency, I would like to call it as F0. You can represent as FR as well. If bandwidth unit is in hertz, F0 also has a unit hertz. If this is in radian per second, this is also in radian per second. Q, quality factor, has no units. Okay. Now see, look at the options. If you look at the options, which option is matching with this relation? You know the value of F0, which is 1 kilohertz, which is 1000. Okay. So if bandwidth is 400 and 40 and 400, if you multiply these two, Q factor and these, are you getting 1000? You're not getting 1000. So A is the wrong answer. A is the wrong answer. Now these 3, yes, you will be getting. If you multiply these 3 and these 2, you'll get 1000. These 2, you'll get 1000. These 2, you'll get 1000. So out of these 3, 1 is right, option A is wrong. So one option is eliminated, luckily. Sometimes if you check it that way, 3 options might be eliminated, but you have to approach in that way. By chance, sometimes it do happen. But this time, it is coincidentally, it is giving 1000 for all these 3 cases. Now we have no other way. If you find at least any one, if you find bandwidth or if you find Q factor, if you find any one value, you can find the other value, or you don't have to find the other value, directly you can mark the option. So for finding out Q factor, what is the formula for Q factor? If you remember the formula, it's good. Otherwise, you can quickly transform this RL series into RL parallel. I have given you a technique how to convert this RL series into RL parallel. If you do that, then see what you're going to get. This is the resistance R prime and parallel inductance L prime and the capacitance as it is. What it did here, I simply converted this series RL into parallel RL. This will be the best technique. This will be the best technique to handle any series parallel combination RLC circuits for resonance case. Okay. Now what's the value of this R prime? What's the value of this L prime? Of course, that is given by the formulas. Okay. So let me give the formula for R prime. R prime is equal to, if anyone knows the formula, quickly You can give it in the chat. R into 1 plus QL square, L prime is equal to L into 1 plus 1 by Q square. Okay. This is what? R prime and L prime values. Okay. Now, what's the value of R value is given, L value is given, QL value, what is QL? It's a quality factor of a coil, which is XL by R. You know the value of omega or frequency, L value, R value, everything is known. You can pretty easily calculate the Q value. If you calculate QL, QL you will get it as 20. QL you will get it as 20. Now this is pretty much enough to answer this. You can say Q factor of this coil itself is the Q factor of the circuit. Q factor of this coil itself is Q factor of the circuit, provided this Q factor is more than 5. Okay, so this Q factor itself I'm calling as total circuit Q factor, provided this Q value is greater than 5. Of course, if it is greater than 10, the approximation is more valid. This is approximate value, but yeah, it is 20, Q is 20. So I can say the approximation is almost valid. So I'm having a guess. This is answer, Q factor of the whole circuit. Then 50 Hertz is the bandwidth, means answer is C. Am I clear? We're not actually solving the questions. This is the way to solve the question. I'm giving a way here to solve the question, but just by finding out the Q factor of this, I'm knowing this Q factor by approximation method. Okay, if you want exact numbers, you solve this and find out, but you don't have to actually. Use these tips so that your time will be saved. Okay, I'm moving on to the next question. Let's see. This is an easy one, come on. Try to answer it as soon as possible.
Academy and make your gate electrical dreams come true. Download the app now.
We got high from night 10 power 3 times. Yeah, share the session. And if you like our AI, you can like it and share it with your friends. This is, again, I'm saying for the first time on YouTube, this all things what you have. If you got something, we need to verify whether it is right or wrong. Let's check.
The first step towards achieving your dreams is having the right coach. Get the best education with PYQs Academy and make your gate electrical dreams come true. Download the app now.
Okay, your time's up. Let's see. My time begins. Again, this will be helpful. You should not be taking much of time for these kind of questions, because this will be helpful for your control systems as well. This is straight away question. Series RLC circuit is connected to a DC source at t is equal to 0. Transience case. Okay, t is equal to 0, which is closed. The transient voltage response across a capacitor C shows no oscillations. See, this is a standard RLC circuit, series circuit, and if you take output across the capacitor, then the transfer function's characteristic equation, you have to remember this. For series at least you remember. Because I said how to get the parallel and series parallel combination, everything I discussed once you know the series RLC circuit. Okay, I discussed those simple tricks in the course. But you have to remember the series RLC. What's the characteristic equation of series RLC? Yes, if you can remember, S square plus RL by S plus 1 by root LC is equal to 0 is a characteristic equation of this if output is taken as here. Now under this case, if you apply control systems logic, zeta must be, it is said, no oscillations. If zeta is equal to 1, it is a critically damped, zeta greater than 1, over damped in both the cases, you will get no oscillations. So no oscillations means zeta value is greater than or equal to, zeta value is greater than or equal to 1. That's the case. Okay, so find out the zeta from this, or else you can directly make it out. The option will be, yes, option R by, see here, R by 2L whole square is greater than 1 by LC. Yes, this is the answer. Okay, this is answer. If under this condition, that's what exactly applied here, zeta greater than or equal. This is also true. This is also true, and this under the equal case also you will get no oscillations, but this is more true because it has a more range. Beyond that also you will not have any oscillations. Okay, so answer is A. You're saying B by saying, I think, critically damped case. That's also a possibility. Okay, I cannot say that's wrong. That can be right. That is also right, because as I said, zeta greater than or equal to 1 will give no oscillations. It's not necessarily just greater than. Okay, so if it is a MSQ questions, you can mark both. Okay, but now as I have MCQ, I have to opt only one. I'm opting for A. If you're opting for B, it's not a crime. That's also right answer. Okay, I'm moving to the next one. Try this.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your
This is a simple one. Come on.
dreams come true. Download the app now.
We got some interesting options for this. Good. People are responding nicely for this. Yes, keep chatting, keep giving your options, keep selecting your options.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Okay, I think everybody answered correctly. Other guys may be just thinking, I think. So let me explain this. Two-port network, these symmetric and reciprocal conditions, these you should try to remember for Z parameters and ABCD parameters and H parameters. For these three, if you remember, you will automatically get the other parameters. Two-port network is said to be symmetrical when the following equalities holds good. if symmetry case, if it is reciprocal, for the reciprocal to happen, this is a condition, Z12 is equal to Z21. For symmetric, no, this is not the case. Z11 and Z22 is a case. Yes, this is true. Okay. And Y12, Y21, this is also for reciprocity case. Okay. And tell me, what if it is Y parameters case? Y parameters case for symmetry, H11 is equal to H22 is a symmetry, but this is not the symmetry case. It's not required, but it is given, so you cannot choose this option. Tell me, what if it is for H parameters, similarly for transmission parameters? Try to list out all those also. That will be helpful for you. Okay. I'll move to the next question because this answer is option B. Okay. So if it is ABCD parameters, A is equal to D is a symmetry case. For reciprocal case, AD minus BC is equal to 1 for reciprocal if it is transmission parameters. Okay. Shall I move to the next question? Cool. Try this.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical.
This is an
Dreams come
interesting
true.
one.
Download the app now.
Good. You got an answer. We need to check whether it is right or wrong.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical. Dreams come true. Download the app now.
Five, 4, 2, 1. Done. Time's up. So let's see what the question says. The question says, here we got two circuits are given. Two circuits are given. One circuit with voltage source and a parallel capacitor. The other circuit is current source and a parallel capacitor. So among these, it is asked for which one is stable. What does it mean, stable or all these things? Stable with respect to voltage, which one is, which of the following is correct in terms of stability it is given. So tell me, what will happen to the voltage, this voltage here at steady state? At steady state, this voltage will be same as the supply voltage, same as the input voltage. Suppose if the input voltage is some X volt, here also you will get some X volt. Now at this case, this voltage, suppose some X ampere is the current, what will be the voltage? Continuously the same X ampere is flowing through the capacitor, constant current is flowing through the capacitor, and the for capacitor case, what's the relation? Relation between voltage and current, V is equal to 1 by C integral I dt. So this constant, if you integrate, you will be getting a ramp. Means the voltage is continuously increasing. It is not settled at any point. It is continuously increasing. So if you apply the stability concept for this, this is unstable. This is unstable. So circuit 1, yes, it is stable. Circuit 2 is unstable. Means What is meant by instability here? Continuously the voltage is ramping up. Continuously the voltage is ramping up. Okay, and it will reach to infinity. Hope it's clear. Is this clear? Give it a thumbs up if it is clear. Give it a thumbs up if it is clear. I'll move to the next question. Next question. Okay. Done. Interesting one. But an easy one, of course. Okay, nothing to worry much about it. The easy one. 1 minute is pretty
First
much
step towards
enough.
achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now. The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
What doing? Come on, solve it quickly. It's an easy one. Though it looks star delta transformation, you have to do all these, but not that much difficult. If you know the formulas, of course. If you don't know the formula, everything is difficult. It's pretty bad that, only one response we got. Okay, well, I'm getting a couple of responses now. Okay, anyways, let's see. The right answer for this, no one, of course, answered correctly yet. Let me explain, nothing to worry. See the way of solving this question within a short time. Of course, you have to answer the question, but within a short time, because it is from state government exams. So there you will hardly have a minute time to answer this. So you need to be smart and accurate, and you need to be quick also. Smart in answering the question. Let's see. With reference to the figure, which of the following is neither ZA, ZB or ZC? Means if you convert this star to delta, you'll get some values ZA and ZB, ZC, and all are present here. Among these, one option is pointing to ZA, another option is pointing to ZB, another option is pointing to ZC, but the one option out of these four is not pointing to either of these three. So what is that? Odd man out. Okay. So for that, you will have to calculate ZA and ZB and ZC. You'll have to calculate all these three. For star to delta conversion, I told you in the course I explained numerators will be same for all these three. Numerators will be same and the denominators. So this is the delta where you are constructing. Okay. So if I want this, then division will be this. Suppose for ZA, this will be divided by 20. For ZB, it will be divided by Z5. For ZC, it will be divided by 10. Okay, which one is ZA, which one is ZB, which one is ZC? How does it matter? For now, it's not that much important. Okay, numerator for all these three is same. What is that? That value will be the numerator. Let me write here. Product of these two, 10 into J5 plus J5 into 20 plus 20 into 10, which is 200. So the result will be, I'm having the number, I'm writing it. It is, if you just simplify this, if I'm not wrong, you should be getting this. This is a numerator which is common for all these three cases. Now simply divide this. You have here simply these numbers, divide this, you will get all these three except fourth option you will not see anywhere. So it is said neither of ZA, ZB, ZC is what? Option D is a 1. So only Ajay Kumar has done that. Others, I don't know what happened to this. Moving on to the next question. Shall we move to the next question? I'm moving. Okay, I moved already. Timer is already running. You need to run. We need to run. Timer is already running.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Okay, I think for this question, 2 minutes of time is not required at all. Maybe 10 seconds is pretty much good enough. Okay. So what is said? The network is said to be under resonance when the voltage and the current at the network input terminals are in phase. If voltage and current, that network is behaving as a pure resistance network. It is a reactive network, but it is behaving as a resistive network. What does it mean? Circuit is under resonance. Okay. So what's the power factor? Unity. What is the imaginary part of the impedance? 0. What is the imaginary part of admittance? Infinity. You can write it in different ways, the way you want. Okay. So answer is both voltage and current, they are in phase. So maybe 10-second question, I think. So move to the next one. Nice that we got some answers at least for this. Ajay has quick on this. Maybe in the next sessions, we'll give some points to those who are answering quickly. We'll get some points also. We'll catch up that in the next sessions. We'll come up with those interesting aspects. The next one. Come on, this is also maybe 10 seconds question. Don't waste much of time for this. Okay. Though timer is running, but you don't have to waste much of time for this.
The first step towards achieving your dreams is having the right coach. Get the best education with Pi Square Academy.
Yeah,
Make your
it's
gate
done.
electrical.
It's done. You all answered it. The internal resistance of an ideal voltage source. We have an ideal voltage source. I have given a tip also. Sometimes people do forget this simple thing also. That's why I given some tips in the course so that you don't have to put your efforts on recalling those. Those things will be automatically remembered in your mind. I think those tips will be so much helpful if you forget the concept by any chance. But of course, if you go with the concept, things will be pretty much easy. But sometimes in a pressure situations, you'll get confused whether it is, internal resistance is infinity or 0. Okay. So in that situation, how to handle all those things are discussed in the course. So ideal voltage source, to be more precise, independent voltage source. Ideal independent voltage source has an internal resistance of 0. Okay. And its characteristics, try to draw its characteristics, recall all those aspects during our practice session. Okay, answer is B for this. The next one, and the easy one, this is also easy one,
Download the app now.
but let's see, what do you feel?
The first step
Okay, I'm
towards
stopping the
achieving your
timer
dreams
at
is
1
having the
minute
right
itself.
coach.
Okay, 1 minute
Get the
itself,
best
I'm stopping the
education with
timer
Pi Square Academy and make your gate
because
electrical
it's
dreams
an
come
easy
true.
one. Okay, that's why
Download
I'm
the
stopping
app
at 1
now.
minute. The time period of third harmonic of power supply frequency in milliseconds for 50 hertz. So 50 hertz time period is 1 by 50 is the time period. So the third harmonic, we know this is equal to 20 milliseconds. 20 milliseconds is 1 by 50. But it is asking for third harmonic component. Third harmonic frequency is 1 by 150. Means 1 by 50 into 3 means 20 milliseconds by 3 means 6.666. 6.666. That's it. The last one of this session. Last question. I'm entering into the last one. Check it. It looks lengthy but easy. Yeah, this option, this also is part of it. This is completely one part. Last one, come on. Keep it up. Push it up. Push your muscles.
The first step towards achieving your
Keep the
dreams
chat
is
up.
having the right coach. Get the best education with Pi Square Academy and make your gate electrical dreams come true. Download the app now.
Krishna Chandra Tiwari has done it. Just 20 seconds more. Come on, give some options.
The first step towards achieving your dreams is having the right coach.
We
Get the
brought
best
some
education.
interesting interaction tool for you, but you guys are like, I don't know. Okay, Madhu is also answered, and we got a couple of answers. Let's see. Let's see. Which of the following statement is incorrect? Okay. So superposition theorem is useful for linear. Yes, it is right. And non-linear circuit, no, it is wrong. It is useful for linear circuits, but it is not useful for non-linear circuits. Non-linear circuits, it is not useful. Okay. So this, the first option itself is wrong. You can verify the other options also. Thevenin's equivalent network consists of one voltage source in series with the impedance. Right. Norton's equivalent consists of one current source and a parallel impedance. Right. When both the load and source impedances are purely resistive, maximum power is transferred under this case. This is also right. So all these three are right. This is wrong. So our option is the wrong one. We need to identify. So this you need to mark. That is it. That is it. That is it. With this, these are the questions we got from 2017 APGENCO and APTRANSCO. Questions from network analysis. So I hope you got some ease of solving the question. Some questions might be already known to you. Some questions you must have got some ideas or some new ideas you must have got. Okay. So we'll keep coming with some more PYQs. But I want your participation because you just have to put that A, B, C, D in the chat itself. Then our AI tool will nicely put up the poll, and shortly we'll be coming up with some points also that will also encourage you. That's the end of this session. If you have anything in general, if you have any questions in general, based on the sessions, based on our YouTube sessions, like we have a couple of videos on why 50 hertz, why sinusoid, why three phase, which normally will not get those insights in some other channels. So if you want any clarification, why 11 kV, based on my explanation, if you have any clarification on that, you're open to ask. I'll give a minute time for you to ask if you have anything. If you don't have anything, I'm happy to sign out the session here and catch you up in the next session. Your 1 minute time starts now. You can keep asking something. Meanwhile, let me go through your chat. Yeah, Madhutej has missed the polarity on one of the questions. Fine, good, 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 good. Okay, so it seems you're having no questions. Or you're all in line with my conclusions. What I discuss, I suppose. So with that, I'm ending the session. Okay, catch you. See you in the next session. Bye bye.